Okay, so once we're done with the geometry and the design criteria, we're going to load our structure with dead load, live load, and earthquake. So let's define our load cases. Click on add, earthquake along X direction. Make sure it's seismic, add, then earthquake along Z direction. You can just enter, then dead load or DL, then live load. Add. So let's proceed first with the dead load. Okay, so let's go ahead with our design criteria again. According here, these are our dead loads. Okay, although we can proceed here on the one-way slab because dead loads are immediately transferred to slab first. Okay, so this is the beauty of the spreadsheet. We have these are updated according to our design criteria. As if you can see, it's all referenced in the design criteria tab. Okay, according here, the total dead load is 4.02, or let's say 4.1. Okay, and their computed dead load thickness is 110 mm. Okay, so we're going to apply 4.1 kPa, assuming very typical from second, third, fourth up to fifth. Okay. Okay, then click on add. But first, let's click on self weight, add, and then the floor load, which is 4.1. Okay. Now this is applied, say, on the second floor. What is its coordinate? This will be our minimum, and this one here is our maximum. Okay. So this is 3.2. So our minimum is, say, 3, and then the maximum is 3 point, say, 3. Okay, this covers the 3.2 coordinate. Then our x is of course 0, then the maximum is 18.2. So let's set this as 19. Our maximum z is 9.5, so let's set this as 10. This is the z. Okay, and then add, close. You may observe self weight is still question mark, so we have to apply this to the whole structure. Then click on assign. Yes, now it's gone. The question mark is gone, and we are correct with applying the floor load in the second floor. Okay, now supposedly we are going to repeat the same procedure on the third floor, fourth floor, and the roof. Okay, there's a technique here, which is, that's why I love Staad editor. Okay, let's click on the Staad editor, save. Then let's inspect our floor load here. What we're going to do is just copy this for the third floor, fourth floor, and the roof, assuming they are all typical. Now, since they are all typical, what only change is the y coordinates, right? So what's the y coordinates? Okay, here is 6.4 for the third floor. Okay, so this is 6.4. So I set this, say, 6. How about fourth floor? 9.6. So I'll change this 9.6 and set minimum, say, 9. Then last is 12.8. Okay, this is 12.8. Then this is 12. Okay. Okay, then save, then close. So very quick, where we updated the dead load, and they're all correct. There's no mistake with respect to application of the load. Okay, how about live load? According to our spreadsheet, it's 2.4 as per our design criteria. Okay, then next is, again, since we were going to apply this as floor load, let's proceed again with our Staad editor. Then copy this, then enter here, and then just update the value. This should be 2.4. Copy, paste, paste, paste. Click on save. Then we're done with dead load and live load. Okay. Next is the earthquake. Before updating this, we must first define our seismic. Okay, then let's proceed with our spreadsheet again. Then let's proceed with here, VNFI, the shear phase shift. Okay, so don't be confused here. These are just arbitrary values, although they are referenced from the weight of each floor. If you plan to manually compute them in the spreadsheet. But what's important here is the parameters here, which we are going to input in Staad. Okay, so as for example, seismic definition, let's try to add. Okay, what code are we going to use? We're going to use 97. Okay, then include accidental load. Our zone is 0.4 here, 4. So this is 0.4. Importance factor is 1.5 since this is a school. Our R is 8.5 in each direction. Again, these values here should be consistent with our design criteria. Our soil type is 4. This is correspondent to SD in our design criteria. Again, they should be consistent. How about NA and V? Thanks to the spreadsheet, it's computed 1.2, 1.6. This is 1.2. This is 1.6. Our CT is 0.0488, although you can manually check this in the NSCP. 0.0488. Then Staad will compute for the period. Add. Okay, then self-weight by default should be added. Close. Now, on the seismic definition, Staad is asking for the seismic weight. Remember the formula F equals MA. There's that here. Okay. Delete. Okay. From the Newton's second law of motion, F equals mass times acceleration. For our NSCP, base shear is CVI over RTW. This W is actually the mass here. This acceleration is actually the coefficient here. So we need W, or the weight or the mass of structure. that will be considered during earthquake, and they are most of typically the dead load themselves. So we need dead loads. So we need to transfer these dead loads up to here. Again, that's okay. I'll come back later. I'll show you another shortcut for this.